Good day, everyone. Today's lesson is similar triangles still, just in cases where they aren't lined up nice. Okay, so nice review yesterday, basically, but just when they're not lined up as nice. So just a quick review to start with. When they are lined up nice, of course, you can look at this and you're told that HYP is similar to ROF. So HYP. ROF. Yep, they are lined up. Good to go. And, if you want to move that to the side, it's okay. Have it not make the diagram a little harder to see. If you look here, you can see easily that you've got corresponding sides there. And then if you're looking for, say, this side here, you can see the corresponding side there. So you can do a between triangle kind of scenario. This one obviously is really easy to see. It's twice as big. And so this big here would be 14, right? So obviously that's fine to do, but you will be asked to do ratio methods as well. So that's sort of that kind of version there. Don't divide by 2 going the other way. If you're showing this as ratios, you're going to identify the side that you're looking for. So the one that I found first, the 14, you can see here's the HY side. And so there it is. We've identified it, start out with it, and then just pick a ratio that you can see is true. So you could do between triangles, or this case here is within triangles, just to show the different types. I can show you the other one too here as well. But anyways, HY over 6, right? Nice little ratio there. That's bottom to right side. So then here, bottom to right side, right? So that's the 7 over the 3. And so you can see you can do the number there. You'd have your H and Y, and then you'd have 6 got canceled out, of course, like that. And so you'd have the 7 times the 6 divided by 3. So the numbers, without a calculator, I suppose with a calculator 42 divided by 3, you might just do that anyways, but just notice that can divide in twice to the 6, giving us 7 times 2, giving us the 14 we said already. Okay. Otherwise, of course, on here, we could automatically just say, okay, well, 20 degrees for that bottom corner, so that's 21 degrees, and 130 for the top, so that's 130. So, right, and 29 for the far left, so 29 for the far left. And so you still label things like angle Y, let's say angle Y at that corner equals angle O. So angle Y equals 21 degrees, dot, 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 just continue to communicate well all of the things, right? So you should have each of the things, the HY side, the RF side, the else, the angles all listed and solved for. Circle them in your work too to make it nice, right? So angle Y is that. You have a similar work for angle O, or no, angle R, I guess it is, and angle F. Right? So that's the kind of thing you got going on for that. In this one here, it's just not nice multiples. So you might find the ratio method a little bit more worthwhile, I guess, in this case here, right? So we are, just do a quick check here, giving them in order. So TRG, like that. The other one's PYN. So same order again. So we can say, yep, they're good to go. And they're all lined up nice. Let's just shrink that down. Done it. We check, they're good to go. And so if we want to say solve for like side TR, well, you just start with TR, right? And put in ratios of size that we know between triangles or within triangles, whatever. So you wouldn't want to do TR over 7, because then you'd have 15 over an unknown, right? So you have too many unknowns. So don't do that. Instead, pick one that you do know, right? So if you went TR over 5.8, then you could say 15.5 over 10. That would work. That's a within triangles ratio. So I'll show that one, and I'll show between triangles. Like I said, I was showing the other page both. I'll just do it here. So TR over 5.8, 15.5. So going that way, go that way again. So 15.5 over 10. And when we solve everything out, we are just going to multiply the size by 5.8 because we're making sure to put the one that we're looking for at the top. Keeps our algebra nice and simple. Flip both sides or all that stuff. Use it as a one-step process, right? So 15.5 divided by 10. And there's a times by 5.8 also going on. So it gives me 8.99. So probably just 9 basically, right? But 99 or 9. So we can list that on there now as TR is 9. Okay. If I was going to do that same side, start with this, or we can start with TR. I was going to do TR with the between triangles ratio set. You just look for a TR over a known side, so you might do, let's do this. Expands out. It's going to be a mess in the end. It's more than one way, but if you're following the video, it should be fine. So TR of 15.5, for example, is a nice marker here, 15.5 down there. And then you need another pair where you know both, right? So you want to go 7 to here, that wouldn't make sense that side. So instead you go 5.8 to 10. Even though this looks kind of different, in the end, as soon as you go and start solving 15 on both sides, you can see that TR is going to be the same stuff as it was last time. We're going to have the 15 times 15.5 times the 5.8, and we're going to have the divided by 10. Okay, so there's lots of options for how you set this up. It's obviously going to give a 9 in the end again. Sometimes there being more than one option makes it kind of difficult, but you know, as long as you're just not sure which one you should do, right? But the answer is you can do either. But the key is just start with the side you're looking for and fill in ratios that you know, right? So that was side TR, similar work for NY and so on. Obviously, angles here, you're going to say that angle G equals angle N because they're in the corresponding spots. So it's equal to 100 and so on and so on. Okay, so I expect to completely finish either of these, but they're just. And we're going to see that kind of stuff in this next slide anyways. Okay, so those are lined up, making the process something you should go ahead and do. Here we have two triangles we're told are similar, but they aren't lined up. So we can check that by seeing we have an ABC order of things, and then here we have like a D, E, F, right? So we can start at the top and swoop around clockwise for both of them. So really, to make this as easy as possible, instead of having to look at it upside down and whatnot, you can redraw the thing. So for me, I'm on a smart board. I'm just gonna rotate it so that it's the same orientation as the other one, right? You put it in there. If you're trying to work from scratch, you literally could just draw it on a separate page and rotate it around, or cut it out of the page and rotate it around. I think I had that on these here. Yeah, this one here, you see, suggesting, if you want, you could cut that thing and, put it beside the other one and make it easy to line up. You can, of course, do this without cutting and whatnot. You would just put a similar shaped triangle here, make it the same kind of size, and then just label it DEF. Right, so label it DEF like it's supposed to be in the same orientation, ABC, DEF, and then just make sure to put the sides in. So if the FD side was given as 10, then make sure to put the FD side in as 10. So that's what we just transfer the information over. So of course, what I've done here is line them up, like I said, right? So this is just showing the idea of without numbers to get to thinking about it, So here is one for you to try. One example for you to try. They're saying they're similar. If you want to give it a try and then get some help on it if you need, or check your work, just press pause and then come back and check what I did. Okay. So let's get going here. If you're getting back into the video here, ABC triangle. So ABC, that, and this one's HLM, so HLM. So you can tell that if I was redraw it as a right triangle, it's kind of skinny and long that way. And I would label it as HLM. So ABC, HLM. In which case I could make sure to put the HM side as a question mark. I could make sure to put the HL side as a 9.75. And I could make sure to put the LM side as a 9. And the L as a question mark. It's not hard to do. It's way easier to do that than it is to try to just, look at it and say, oh, well, this one corresponds to that because it's over here and that one's over there instead, and so on. It's just kind of confusing, right? So on the smartboard, of course, I would just take this and rotate the exact thing and put it in there. And even though the labels are not upside down, you can see the H and the M, and the question mark, and the 9.75, the H and the L, everything's where it should be. The only trouble is the 9 starts to look like a 6, right? Which I can fix with the smartboard as well. So I can just grab that and rotate them both. There we go. Technology, right? But anyways, so that is what you're going to want to do, right? So the hand-drawn version is perfectly fine as well. Get rid of our directionality check here and just go for it. So with this one here, let's say we want to solve for HM first, right? So we're looking for that one. So let's go HM, top, nice. Just pick a ratio that we know. So if we went between triangles, right? If we went between triangles, we might go, to the other side, other vertical one. So you have HM over 5. And then you need another pair of sides where you know both. So you can't use 9.75 unknown. Instead, you're going to have to use 9 to 12. Right? So going 9 to 12. HM to HM over 5, so we're going to go 9 to 12. So that one's all set up. I go 5. End up with M equals 9 times 5 divided by 12. 9 times 5 divided by 3.75. And so we figured out that this side here is 3.75, our HM side. So we got that one. And then if we want to get the AB side, maybe I'll do a within triangle in this one just to show both types of methods. So for within triangle, you can look and say, well, if I did the slant side over the bottom that was given, then I could do the slant side over the bottom that was given there. Right? So AB over 12. And notice I wouldn't want to necessarily want to do the 5 over the question mark over 5, because then I'd do 9.75 over to unknown. So you'd be trusting your 3.75. But yeah, you could see 3.75. So AB over 12. And the other one was 9.75. So multiply by 12. Multiply by 12. After AB left over here as 9.75 times 12 divided by 9. Just use a calculator. It's 13 here. And the other bit would just be to say that, if you wanted angle L, you just say, well, that corresponds to angle B. So we have angle L. Space. Angle L equals angle B. And so it equals 23 degrees. Right? All of this, by the way, you should start out with, since triangle 1 similar to triangle 2 and so on, but it's obviously given here, right? Soon we're going to have to sort of check this for certain conditions to show that they're similar. But here it's just given. So similarly here, A equals, it's going to be the same as angle H. Oh, shoot, we don't have that one, right? So we're going to have to, use some of the angles of a triangle, I guess, then instead, right? So that's just a dead end here. So it's, oh, that didn't work. instead, we're gonna say for angle A, we can say angle A plus 23 degrees plus 90 degrees adds up to 180 because some of the angles in the triangle here is SAT. You just solve out. So the 180, take away the 90, take away the 23, gives us 67 degrees. Work nice here, of course, right? Take away 23, 90, 90, and then say angle H equals angle A, and so angle H equals 67, and that's just because they're corresponding angles. Okay. We've got angle H, we've got angle A, we've got the sides we're missing. We're done. Okay, so practice questions to do there, and take a nice picture of. Use that as a page PDF file for me to use, submit that, and I'll keep you on track. All right, if you have any questions, email me, message me on Teams, or email me, in best email in D2L or ask the message email service in D2L, so that's because I can categorize every email I get categorized into a folder for you, so I can help keep track of what you are looking at for getting help. All right, so don't hesitate to contact me. Watch the videos, learn the stuff, practice the stuff, get help if you need, and we'll get you through. Okay. All right, save that file. We're done. Here we go.